Let's look at factoring completely 30x to the fourth y squared plus 93x cubed y cubed minus 42x squared y to the fourth. We notice that 3 is the largest integer that divides evenly into every term of this polynomial. So our GCF will have a 3 in it. Every term has an x, so the GCF will have an x. The highest power of x common to every term is x squared. Every term has a y, so the GCF has a y. The highest power of y that divides evenly into every term is y squared. This GCF multiplies by 10 x squared in order for me to get the first term, 30x to the fourth y squared. The GCF multiplies by 31 xy to give me the middle term of 93x cubed y cubed. And then the GCF multiplies by negative 14 y squared to get the third term of negative 42x squared y to the fourth. So I'm going to factor this polynomial in parentheses 10x squared plus 31xy minus 14y squared using the AC method. A is 10, C is negative 14, and that multiplies to give me negative 140. So I'm looking for two integers that multiply to give negative 140, and if two integers multiply to give a negative, one of them has to be negative. These have to add to give me my B, which is 31. So the two integers have to multiply to give a negative 140, and they have to add to give 31. Same two integers have to add to give 31. So I want the two integers to multiply to give negative 140. I see 10 and negative 14 are two factors of negative 140, but those are not going to add to give 31. So I look for other factors of negative 140 that add to 31. So clearly 7 will go into 140. The smaller integer needs to be negative, but negative 7 times 20 gives negative 140, but adds to 14. So those aren't my numbers. I notice that 5 goes into 20, so I'm going to see how many times 5 goes into 140. It goes in 28. Negative 5 times 28 gives me negative 140, but only adds to 23. So I'm going to try 4, which goes into 140 35 times. So negative 4 times 35 gives me 140, negative 140, and adds to give 31. So these are my two integers. So I'm going to use these two integers. So notice how I'm recopying the GCF. I'm going to use these two integers to rewrite 31xy as negative 4xy plus 35xy. And then I make no change to the 10x squared and the negative 14y squared. And now I'm going to factor by grouping. The GCF of 10x squared and 4xy is 2x. And that multiplies by 5x minus 2y to give me those first two terms back. So there's got to be a GCF that I can factor out of the last two terms that also multiplies by 5x minus 2y. And I see that that's a positive 7y. Positive 7y times 5x gives me positive 35xy. positive 7y times negative 2y gives me negative 14y squared. So the factors are 3x squared y squared times 5x minus 2y times 2x plus 7y. And so I go back to my math lab, and I want to put that in for my factorization of this polynomial.